a few billion years, scientists predict that our universe may face a catastrophic event known as the Big Crunch. This is when all matter, stars, galaxies, everything, will start collapsing back into a dense state, leading to an intense, high-energy ending. But what if that's not the whole story? According to Professor Roger Penrose, our understanding of the universe's end may be far from complete. He proposes that in the distant future, another Big Bang could occur. I've come to the view that there was something before the Big Bang, and it goes on expanding. It's now indulging in what's called the exponential expansion, which is caused by what people call dark energy. In other words, he argues that the Big Bang isn't a one-time event, but rather an optical illusion of sorts. The universe might go on forever, not in a repeating cycle of Big Bangs and Big Crunches, but in a continuous, unending sequence. He even boldly claims that this is the evidence of a previous universe existing just before ours. And he said that with great certainty, the evidence for it is really quite strong. The strength of the signal we see is at a 99.98% confidence level, which is pretty strong. A single black hole gradually swallows most of the cluster, all that energy bursts through onto the other side. So, what is the piece of evidence Professor Penrose is claiming, and what could it mean for the distant future of our universe? Conformal cyclic cosmology. Back in 2019, Roger Penrose co-authored a research paper published in the Royal Astronomical Society titled Apparent Evidence of Hawking Points in the CMB Sky. In this paper, he and his team claimed to have found several anomalies, potential evidence of a universe that existed before our own. As stated in their research, each anomalous spot would have originated from a highly energetic point-like source, resulting from the Hawking radiation of supermassive black holes in a cosmic eon prior to our own. Simply put, these dark spots may represent actual evidence of a previous universe, or as Penrose describes it, an eon rather than a universe. We covered this in detail in our previous video here, but just to recap, this idea falls under the framework of conformal cyclic cosmology, CCC. It replaces the traditional inflation model with a lambda-driven, exponential expansion of a universe epoch, referred to as an eon. In this view, our universe is one in an endless sequence of eons, each starting with its own Big Bang. It's important to note that the lifespan of each eon could stretch up to a googol years. And if time truly extends infinitely, the idea is that another Big Bang would eventually occur. What remains in this remote future is the ultimate fate of black holes. Penrose suggests that some of these supermassive black holes from a previous universe might become bound to the conformally stretched Big Bang of the next eon. The observed anomalies are proposed as evidence of this connection. Here, we must make it very clear that these claims are highly controversial and not widely accepted within the cosmology community. Where's the evidence? But let's take a step back for a bit. How does one argue that these spots are definitive evidence of black holes from a prior universe? Well, it all circles back to a concept long proposed by the late Stephen Hawking, known as Hawking radiation. The whole point is pretty straightforward. We are able to observe dead black holes left behind by earlier eons. These black holes, possibly as massive as 10 to the power of 14 times the mass of our Sun, would have evaporated through Hawking radiation. And so, in the grandest picture of this concept, these remnants would form what is referred to as a Hawking point. The so-called warm points, which are all about 8 times larger than the diameter of the Moon. As Penrose stated in his paper, we must bear in mind that, despite Hawking radiation being of an absurdly tiny temperature, over the eon's history, the entire mass energy of the black hole will be finally radiated away. And in the conformal picture, this will take place within what would effectively be a single Hawking point H. Since we know that the Hawking evaporation of a supermassive black hole would generally take much longer than the current age of our universe, some information from a previous eon may seep into the next cycle. If you're interested in the full details, we recommend reading the paper yourself. There's a link in the description below. But without delving into the nitty-gritty details of what he mentioned in the paper, he and his team identified several characteristics of these Hawking points as anomalies in the CMB map. Now, for the moment you've all been waiting for, where exactly is this evidence on the map? These are their galactic coordinates, and if we map them visually, here is where they appear. According to the equations, what you find is that these signals should influence the dark matter in the next eon, and you should be able to see signals, although these signals aren't something we perceive in our daily lives. An analogy should be able to illustrate this. Think about when we're browsing or shopping online. Our data doesn't just stop there, it often leaves traces without us even realizing it. This information gets passed along to other merchants, platforms, eventually data brokers, where it can be bought and sold, even in places like the dark web. So, it's similar to the signals Penrose described. The echoes from the past can persist into the future eons. But unlike those remnants, we actually have the power to manage our digital footprints. And that's why we're excited to partner with Incogni for this video. It's a service that helps users protect their personal data without the hassle of contacting each data broker individually. When you sign up for Incogni, you're basically giving them the green light to get you off as many of these lists as possible, and then they start securing your privacy. It's a process, but Incogni keeps you updated along the way. They put it all on this dashboard, so you can see exactly what's going on, maybe even hundreds of lists where your email, phone number, or address is floating around. You can literally watch the tally go down as they remove you from more and more lists. In the US, there's a massive issue with people search sites. You know, those creepy sites where you type in someone's name, and it pulls up every bit of info it has on them. But Incogni is on it. They sniff out those sites and get you off those lists too. You can sign up and try it out for 30 days. Head over to this link, incogni.com/bond ideas. You'll get an exclusive 60% off their annual plan. Challenging Penrose's CCC. Penrose reiterates his belief in what he humorously calls a crazy theory of mine. He suggests that our universe will continue to expand until all matter decays, and then a new Big Bang will occur. But occasionally,
remnants from a previous eon may seep into our current one. But does this theory fully explain our universe? The biggest difference in predictions between CCC and inflation theory lies in what we should expect to see. CCC suggests that we would find imprints of a universe before the Big Bang, visible in both the large-scale structure of our universe and in the CMB. On the other hand, inflation theory requires that any point where inflation ends and a hot Big Bang begins must be causally disconnected from other regions. To put it simply, each region of the universe should not show any interaction with another, the past, present, or future. Our universe's properties should be independent of any preceding universe. Observations from missions like COBE, WMAP, and more recently, Planck, have put very tight constraints on the existence of such structures. We see no evidence of repeating patterns, concentric circles, or Hawking points in the universe. When the data is analyzed properly, the findings consistently support inflation and not CCC. Although Penrose has his supporters, the scientific consensus strongly disagrees with his conclusions. Many scientists have pointed out that his predictions are not supported by the data, and any claims of finding such effects seem to rely on what they argue is a flawed or unsound interpretation of the data. Despite that, Penrose continues to advocate for this CCC idea. When I had these various ideas, I could go on lecturing about this forever because nobody will ever know whether it's right or not. What's interesting is that, while Penrose references theories by Stephen Hawking, Hawking himself had a different view. In his 2010 research paper, Hawking stated, "Our universe seems to be one of many, each with different laws." He believed in the hypothetical set of all universes, a perspective quite different from Penrose's cyclic cosmology. In his own words, our cosmic habitat, now the entire observable universe, is just one of many. Speaking of the multiverse and how it relates to CCC, as briefly mentioned earlier, each cycle of an eon lasts for about a googol years, a staggering number that is 1 followed by 100 zeros. So, a googol years is 10 to the power of 100 years. Googolplex multiverse. After such a long period, a new eon begins, and this cycle continues endlessly. So, one of the intriguing questions that arise is, if the universe continues on for eternity, would it eventually lead to another Big Bang or perhaps a Big Crunch? What are the consequences of such an endless cosmic cycle? In order to address this, we need to revisit a term known as the phase-space volume. It's a theoretical space that represents all possible states that the universe can exist in. This volume is an astonishing 10^10^123 cubic meters. It's so vast it defies conventional understanding of time and space.